After you feel confident in building reports and dashboards, you'll naturally move on to more advanced analytical techniques. In this lecture, we'll introduce you to cloud-based data storage and access techniques, support for Python and the programming language in Power BI, and predictive analytics. We'll also walk you through a common modeling approach called linear regression. Linear regression modeling will be your entrance into the broader area of data science and machine learning. These topics will tee you up to expand on the fundamental hockey analytics topics covered in this course.
In this lecture, we'll cover 3 advanced topics: an overview of data providers and the cloud, the possibility of R and Python integration with Power BI, and the difference between descriptive versus predictive analyses. With regard to the first topic, the availability and accessibility of data have revolutionized the way we understand and analyze the game. As you're hopefully beginning to see from this course, data providers play a crucial role in the analytical process. Moreover, the advent of cloud computing has further transformed the landscape of hockey analytics and data management. The cloud allows us to store, process, and analyze vast amounts of data efficiently, enabling real-time insights and collaboration among analysts, coaches, and teams. With regard to the second topic, integrating R and Python with Power BI enhances our ability to visualize and communicate data effectively. Power BI enables us to create interactive dashboards, reports, and data visualizations that provide actionable insights to coaches, players, and front office personnel. In this course, we focused a little bit on Python, but both Python and R are popular programming languages when it comes to data science and data analysis. Furthermore, they both integrate with Power BI. And with regard to the third topic, in the realm of hockey analytics, we encounter 2 key approaches: descriptive and predictive analytics. Descriptive analytics focuses on understanding what happened in the past, providing a comprehensive overview of historical data, player performance, and team trends. On the other hand, predictive analytics leverages statistical models and machine learning algorithms that use historical data to forecast future outcomes, such as player performance, team success, or even game results. Let's explore some of the different types of data sources that hobbyists can utilize. One popular data source we've used in this course is mysportsfeeds.com. In addition to mysportsfeeds.com, hobbyists can also leverage official NHL data sources. The NHL provides a wealth of information on their official website, including player profiles, team statistics, and game results. This data can be manually extracted or accessed through NHL APIs to populate fantasy hockey dashboards with accurate and up-to-date information. Furthermore, there are various third-party data providers and offer APIs and data feeds specifically designed for fantasy hockey. These sources may include player projections, injury updates, expert analysis, and customizable scoring systems. While we've covered some of this, below you can see a code snippet for integrating with mysportsfeeds.com. This is a boilerplate template they provided on their website. The given code snippet performs the following operations, line by line. 1. Imports the base64 and requests modules, which are required for encoding credentials and making HTTP requests, respectively. 2. Defines a function named sendRequest. 3. Starts a try-except block. 4. Within the try block, sends an HTTP GET request using the requestsGet method. It uses the URL parameter to specify the URL to which the request is sent. Here, you would replace the pull URL with the actual URL. 5. Passes query parameters to the request using the params parameter. In this case, it sets the for-date parameter to 2016-11-21, indicating a specific date. This provides a parameter for the data that will be returned from the API request. 6. Sets headers for the request using the headers parameter. It includes an authorization header with a basic authentication scheme. The username and password are encoded using base64 encoding. Replace API key token with the actual API key token. 7. Prints the HTTP status code of the response using the response status code attribute. 8. Prints the content of the response body using the response content attribute. 9. Closes the try block. 10. starts an accept block specifically for handling exceptions related to failed HTTP requests. 11. Prints a message indicating that the HTTP request failed. Overall, this code snippet defines a function called sendRequest that sends an HTTP GET request to a specified URL. It includes query parameters and authentication headers. It then prints the response's HTTP status code and content. If an exception occurs during the request, it prints a message indicating the failure of the HTTP request. When it comes to other data sources, there are 4 key takeaways we wanted to reinforce in this course. 1. There are many sports data providers, so be sure to explore what's out there and pick something that works for you and your budget.
The NHL has a comprehensive set of APIs. There is not an official set of documentation, but there are some sources out there that give you a good starting point to explore them. Here you can see an unofficial GitHub page with lots of endpoints that you can explore. We're using a JSON viewer to inspect the response from one of the NHL APIs.
Apart from the MySportsFeeds.com data provider, there are numerous other providers available in the market. These providers offer a wide range of sports data, each with its own unique offerings and features. 2. Each comes with their own cost and programmability, so research to understand how much a data source will cost you. Different sports data providers have their own pricing structures and levels of programmability. The costs associated with accessing their data may vary, and their APIs or data formats may require specific adaptations or configurations to integrate with your solution. Be on the lookout for hidden costs, such as transactional costs, or the cost to ramp you or someone else, or even other systems you'll need to implement to handle different data formats or APIs. 3. The Python code we walked you through in this course needs to be adapted if you want to use other data sources or even shape your data wrangling process differently. That is, when integrating with different sports data providers, the Python code used for data retrieval and processing here may need to be adapted or modified to align with the specific requirements or APIs of each provider. However, the rest of the overall solution we built in this course with you, including the data visualization and analysis part using Power BI, could be updated with relative ease. 4. Explore Power BI consuming commercial APIs directly. Instead of relying solely on custom Python code for data retrieval and processing, another option is to explore the possibility of directly consuming commercial APIs in Power BI. Power BI offers the ability to integrate and consume data from various commercial APIs, including those provided by sports data providers. This allows for a more streamlined and direct integration without the need for extensive custom code development. Moving and managing data from a local environment to the cloud offers various options and possibilities. Here's an overview of different approaches to achieve this. 1. Keep using CSV files, but move them to AWS. If you're comfortable working with CSV files, you can transfer them to an Amazon Web Services (AWS) environment. AWS offers storage services like Amazon S3, where you can upload and store your CSV files securely. From there, you can access and manipulate the data using other cloud services. Microsoft Azure is another cloud provider, which also has many cloud services available for you to use. 2. Write CSVs to S3. Instead of keeping CSV files locally, you can directly write them to an S3 bucket in the cloud. This eliminates the need for local storage and provides scalability and durability benefits. Power BI, a popular business intelligence tool, can then read the CSV files stored in the S3 bucket, allowing you to create insightful visualizations and reports. 3. Migrate from CSV to cloud-based data store. If you're ready to move away from CSV files, you can consider migrating your data to a cloud-based data store. For example, you can use Python to update a SQL server or another type of data store hosted in the cloud. Once the data is in the cloud-based data store, Power BI can seamlessly read from it, enabling you to build dynamic visualizations and gain valuable insights. 4. Create your own REST APIs in the cloud. Another option is to leverage the cloud to build and host your own REST APIs. By developing APIs in the cloud, you can expose your data to other applications or even sell access to those APIs to external consumers. Power BI can consume these APIs, allowing you to integrate your data and visualizations seamlessly. Overall, these different approaches provide flexibility in moving and managing data from a local environment to the cloud. Whether it's leveraging CSV files in AWS, migrating to a cloud-based data store, or building your own APIs, the cloud offers a range of options to enhance data accessibility, scalability, and collaboration, while utilizing powerful tools like Power BI for data analysis and visualization. The integration between Python and Power BI brings the power of Python scripting to enhance data analysis and visualization capabilities within the Power BI platform. Here's an overview of this integration, focusing on installation, configuration, and limitations. 1. Integration of Python with Power BI. With Power BI, you can seamlessly incorporate Python scripts into your data modeling, analysis, and visualization workflows. This integration allows you to leverage the extensive capabilities of Python, including its rich libraries and statistical functions, to perform advanced calculations, data transformations, and machine learning tasks. 2. Installation and configuration of Python in Power BI. To enable Python integration in Power BI, you need to ensure that Python is installed on your machine and properly configured. This involves installing Python and the required libraries, setting up the Python environment, and configuring Power BI to recognize and interact with Python scripts. The exact steps for installation and configuration may vary depending on your operating system and Power BI version. 3. Limitations of Python in Power BI. While the Python integration in Power BI offers flexibility and functionality, there are certain limitations to be aware of. For example, Power BI supports a subset of Python libraries, so not all Python packages may be available within the Power BI environment. Additionally, the execution of Python scripts within Power BI is limited to the Power BI desktop application and may not be available in the Power BI service or shared reports. It's important to keep these limitations in mind when planning and designing your Power BI solutions involving Python integration. However, despite these limitations, the integration still provides significant opportunities to leverage Python's extensive ecosystem and capabilities within the Power BI platform. By integrating Python scripts directly into Power BI, users can enhance their data analysis and visualization workflows, leverage powerful Python libraries, perform complex calculations, and even apply machine learning algorithms. This integration offers a seamless and efficient way to harness the combined strengths of Python and Power BI for comprehensive data-driven insights and decision-making. The integration between R and Power BI offers a seamless and powerful combination for advanced data analysis, predictive analytics, and machine learning within the Power BI platform. Here's an overview of this integration, focusing on its capabilities, installation, and configuration. 1. Integration of R and Power BI. In addition to Python, Power BI provides native integration with R, another popular programming language for statistical computing and graphics. This integration enables you to leverage the extensive capabilities of R within the Power BI environment, empowering you to create complex and sophisticated analyses. 2. You can create powerful advanced analyses in Power BI. By integrating R scripts into Power BI, you can perform a wide range of advanced analyses. This includes regression analyses, predictive analytics, time series forecasting, clustering, and other statistical modeling techniques. R's vast collection of packages and libraries allows you to access a wealth of pre-built functions and algorithms for comprehensive data analysis. 3. Installation and configuration is required. To utilize R within Power BI, you need to ensure that R is installed on your machine and properly configured. This involves installing R and the required R packages, setting up the R environment, and configuring Power BI to recognize and interact with R scripts. The exact steps for installation and configuration may vary depending on your operating system and Power BI version. The integration of R and Power BI opens up a world of possibilities for advanced analytics and machine learning. By leveraging R's extensive capabilities, you can perform complex statistical computations, create predictive models, and generate visually appealing and interactive reports and dashboards in Power BI. While installation and configuration are necessary, the benefits of integrating R and Power BI are substantial. This integration empowers users to perform advanced analyses and derive actionable insights from their data, ultimately leading to more informed decision-making and improved business outcomes. In summary, the integration between R and Power BI enables users to harness the power of R's statistical computing and modeling capabilities within the Power BI environment. This integration, coupled with Power BI's data visualization capabilities, provides a comprehensive platform for performing advanced analytics and unlocking the potential of data-driven insights. The provided R code, embedded in an R visual script control within Power BI, performs data manipulation and generates a scatterplot visualization using the ggplot2 library, essentially a low-grade linear regression. Here's a summary of the code. The code begins with a preamble, where a data frame named dataset is created using the variables FO% and points. The dataset is then processed using the unique function to remove any duplicated rows, ensuring that only unique observations are considered. The above code is auto-generated by Power BI when you drag and drop the data fields into the properties of the R visual script control. The code appears to be commented out, but is used by Power BI and can be referenced by the R code you write into the R visual script control. The subsequent code utilizes the ggplot2 library, which is loaded with the library ggplot2 command. This library provides powerful tools for creating visualizations. The ggplot function is called with the dataset data frame as the first argument. It specifies the aesthetics of the plot, where FO% is assigned to the x-axis and points to the y-axis. The geom point function adds individual data points to the plot. Each point represents a combination of face-off percentage, FO%, and points from the dataset. The geom smooth function is used to add a trend line to the scatter plot. The method equals LM argument specifies that the trend line should be a linear regression line. The SE equals false argument removes the shading around the trend line, and color equals red sets the color of the line to red. The labs function is used to label the x and y axes with face-off percentage and points, respectively. Finally, the theme minimal function sets a minimalistic theme for the plot, removing unnecessary background elements and grid lines. Overall, this code demonstrates how to create a scatterplot visualization in Power BI using R. It emphasizes the relationship between face-off percentage and points, providing insights into potential correlations or trends between these variables. In essence, it's a linear regression represented through a scatterplot. To add an R script visual to Power BI and create a linear regression chart comparing total points with face-offs in hockey using ggplot2, follow these steps. 1. Open Power BI Desktop and load your data into the report. Ensure that your dataset includes columns for total points and face-offs. 2. In the Visualizations pane, click on the R Script Visual option to add it to the canvas. 3. In the Fields pane, drag and drop the total points and face-offs columns into the Values field well of the R Script Visual. 4. In the R Script Visual pane, click on the ellipses button next to Script to open the R Script Editor. 5. In the Script Editor, add the code below. 6. Click the Run button or press Ctrl-Enter to execute the script and generate the visualization. The R script visual will display the scatter plot with the linear regression line. 7. Customize the visual as desired by adding labels, colors, and themes using the ggplot2 syntax. For example, you can modify the axis label, change the color of the regression line, or apply a different theme. 8. To interact with the visual, such as selecting data points or filtering based on other visuals, Power BI will pass the filtered dataset to the R script automatically.
The script controls in Power BI don't have to live by themselves. In fact, after you create a linear regression model in Power BI using R, you can also add other controls to create a fully interactive dashboard. For example, here you can see we've gone beyond the simple linear regression control to have a team slicer control and a scatter chart. As a part of a dashboard, the script control is fully interactive. That is, when you select one or more teams on the slicer control, the data in the linear regression control is also filtered.
By following these steps, you can add an R-script visual to Power BI and create a scatter plot with a linear regression line, comparing total points with face-offs in hockey using ggplot2. This allows you to gain insights into the relationship between these variables and visualize any trends or correlations. Descriptive statistics and predictive modeling are two fundamental approaches used in analytics to gain insights from data. While they both serve different purposes, they're equally important in understanding and interpreting information. Descriptive statistics focuses on summarizing and describing the data we have at hand. It helps us understand the characteristics, patterns, and relationships within a dataset. Think of descriptive statistics as a way to paint a picture of what the data looks like. Descriptive statistics include measures such as averages, mean, median, measures of variability, standard deviation, range, measures of central tendency, mode, and graphical representations like histograms and scatter plots. These techniques provide a snapshot of the data and enable us to identify trends, distributions, and outliers. They answer questions like, what's the average age of the customers, or how is the data distributed? Predictive modeling focuses on using historical data to make predictions or forecasts about future outcomes. It aims to identify patterns and relationships within the data to create models that can be used to predict future events or behaviors. We see this all the time with the weather. Previous weather patterns are used to predict future weather events. Predictive modeling involves using various statistical and machine learning techniques, such as regression, decision trees, or neural networks. These models learn from historical data and use it to make informed predictions. For example, a predictive model could be used to predict customer churn, forecast future sales, or classify whether an email is spam or not. Unlike descriptive statistics, predictive modeling requires a deeper analysis of the data and the creation of a mathematical model that can be applied to new, unseen data. It involves training the model on historical data, evaluating its performance, and then using it to make predictions on new data. Well, congratulations are in order. You've reached the end of the course, and while it may not seem like it, we covered a lot. As a recap, some of the topics we covered are as follows. Common hockey statistics that you can use as a hockey hobbyist, fantasy hockey enthusiast, or other analytical needs. What is Power BI and how you can use it to build your first hockey dashboard. How to use mysportsfeeds.com as a data source for your hockey dashboard. How to integrate Python, Excel, and Power BI as a multi-tiered application. Descriptive and predictive statistical approaches and analyses. How to integrate R into Power BI for advanced predictive analyses. What we showed you in this course is only the tip of the proverbial iceberg. You can go even deeper on each of the topics we covered to learn more advanced techniques that give you super useful and advanced analyses of hockey statistical data. We hope you've enjoyed the course and will rate us high, but more importantly, we hope that you take the knowledge and skills you've gained from this course and explore and apply it in your own life. Thanks very much for taking our course. We hope to see you in future courses.